Hello everyone, welcome back. In this video, I will be covering section 3.6, derivatives of logarithmic functions and inverse trig functions. So far we have seen a lot of rules about derivatives. We started off with the derivatives of polynomial functions, exponential functions, power rule, sum, difference, product rule, quotient rule, chain rule, then how to do implicit differentiation. And after that, now we are going to do logarithmic differentiation. So derivative of log of x to the base a is a constant. The rule is it's 1 over x ln of a. 1 over x ln of a. Therefore, derivative of ln of x, d by dx of ln of x. ln x means the base is e, Euler constant. So ln x, another way of writing it, it's log of x to the base e. So if you apply the same rule that we did earlier, that is 1 over x, then ln of the base, ln of e. But what is ln of e? It is equal to 1. So derivative of ln x is just 1 over x. Combining the previous rule with the chain rule, we get d by dx of ln of u, where u is some function of x, let's say. Then we have to differentiate this outer derivative and then inner derivative. We use the chain rule. So it is ln of u with respect to u. So d by dx, d by du of y times du by dx. This will turn out to be 1 over u, which is the outer derivative. Then derivative of u with respect to x would be just du by dx. Let's take it that way. So 1 over u du by dx. What is derivative of ln of something? So ln of g of x. So it's 1 over g of x times derivative of g of x. Derivative of g of x. In general, if you have ln of, let's say something, a box, let's say. So it will be 1 over that box, 1 over that box times derivative of that box. It's 1 over g of x, then derivative of g of x. So let's try problems based on this. Derivative of ln of sine x. So it is outer derivative, which is 1 over sine x. So whatever is the argument of ln that goes in the denominator times derivative of sine x. So which will be cosine x over sine x. Derivative of sine x is cosine x. It can also be written as cotangent x. Let's try the next one. Derivative of ln of x plus 1 over square root of x minus 2. Though we study logarithmic derivatives, ln properties, log properties are sometimes useful. So what is the product rule for logarithms? So ln of x times y is ln of x plus ln of y. That is product rule. So this is algebra that we did earlier. Then quotient rule for ln. So it's ln of x divided by y is ln of the numerator minus ln of the denominator. They're connected by minus. And that is something called the power rule for ln. All these are rules for ln, logarithm. ln of x to the power m, then you can bring the m in front of the ln of m times ln of x. We'll be using these three properties quite often. So now d by dx of ln of x plus 1 over square root of x minus 2. Let's do the algebra first and then we'll take the derivative. You can also do without that algebra part, you can actually jump into doing 1 over the box times derivative of the box type, you can do that. But if you do ln property, then it makes our problem, it is little easier and looks better. So ln of the numerator minus ln of the denominator by what we have seen. This is quotient rule. But while we do that, it's ln of x plus 1. Then this x minus 2 can be written as x minus 2 to the power 1 half. Now I use the power rule and write this as half ln of x minus 2. Now let's do the derivative, then it becomes much simpler and elegant. So ln of x plus 1 over square root of x minus 2. So it will be d by dx of the first one, which is ln of x plus 1 minus ln of half of ln of x minus 2. Derivative of the first, then derivative of the second, d by dx. So derivative of ln of x plus 1. So imagine that this is the argument, ln of something. So it will be 1 over that something. Then derivative of that x plus 1 is after all 1 minus half can be pulled out. Then ln of x minus 2 in the argument. So it will be 1 over x minus 2 times derivative of x minus 2. So it will be 1 over x plus 1 times 1 minus 1 over 2 times x minus 2. Derivative of x minus 2 is 1. If we want, we can simplify this. So this would be, if you do the algebra, 1 over x plus 1 minus 1 over 2 times x minus 2. The LCD is going to be 2 times x plus 1 times x minus 2. So if I multiply this by 2 times x minus 2, they'll have 2 times x minus 2 up. It will be x plus 1 here. So x plus 1 here. So it will be 2x if you distribute minus 4 minus x minus 1 on the numerator, 2 times x plus 1 times x minus 2. So it is 2x minus x, combine the like terms, then minus 4 minus 1, that's a minus 5, divided by 2 times x plus 1 times x minus 2. That is actually the derivative of the given problem, ln of x plus 1 over square root of x minus 2. Sometimes it's easy to do the problem ln as is. Sometimes if you do the derivative, if you do the ln property first and then do the calculus part, then it will be much simpler. So what is ln of derivative of ln of absolute x? So absolute x is defined to be, absolute x is x whenever x is more than or equal to 0. It is negative x whenever x is less than 0. So if I assume x to be more than or equal to 0, ln of absolute x would be ln of x. So derivative of the ln of absolute x would be derivative of ln of x. So this is the first case we consider. This is case 1. So it will be 1 over just x, right? Then if we assume case 2, x is less than 0, then ln of absolute x would be ln of absolute x equal to negative x, right? So it will be negative x here. So if you do the derivative of ln of absolute x, that is d by dx of ln of negative x. This would be 1 over negative x times negative 1 by chain rule. So it is, what do you have to do? 1 over the argument and then derivative of the argument, right? So it's 1 over x, then derivative of negative x. 1 over negative x times derivative of negative x. So that will become negative 1 over negative x. That will be 1 over x. So what we notice is in either case, whether x is positive or 0 or negative, ln of absolute x turns out to be 1 over x. So here you would write 1 over x. So now there are 4 or 5 cases here. In general, there are 4 cases for exponents and bases. So if the base is a number, exponent is also a number. A is a constant, B is a constant. A to the power B is a constant. So the whole thing is a constant. So a derivative of a constant equal to 0. Where the base is a constant, exponent is a constant. Now let's consider d by dx of f of x to the power b. F of x to the power b. So here the exponent is a constant. The base is a variable, or it can be considered as a function. So you have to do the chain rule, which is the outer derivative times inner derivative. Outer is exponent, function, exponent minus 1, that is outer derivative. And this one is the inner derivative. Chain rule here. So it is b f of x to the power b minus 1 times derivative of the inside, derivative of f of x, which is f prime x. The third, d by dx of a to the power gx. Here notice that a is a number, base is a number, base is a constant. So a to the power g of x, if you remember earlier when we did d by dx of a to the x, we said that it is a to the x ln a, right? This is what we said. So here, instead of x, we have a function g of x. So it's a to the g of x times ln a. Not only that, we should also differentiate the gx. That is something like inner derivative. So again, chain rule brings in this g prime x. That's a to the g of x times ln a times g prime x. This also follows from the chain rule. Then to find d by dx of f of x to the power g of x, you note that here base is a function. The exponent is also a function. If this is the case, then the only option is that we have to do logarithmic differentiation. We'll see problems based on this whole thing. Also, from algebra, we know that limit is x approaching 0, 1 plus x to the power 1 over x equal to E, the Euler constant. So you have a specific button in your calculator for E, Euler constant. Then its limit is n approaching infinity, 1 plus 1 over n to the power n. It's a modified version of this. If you take x equal to 1 over n, this is what you did in the previous one. So limit is n approaching infinity, 1 plus 1 over n to the power n will also be E. So E is the Euler constant. All right. Let's try some problems based on this. Differentiate y equal to x to the power root of x. So what do you notice in this function? So base is the x, which is a function. Exponent is the root of x, a function as well. So both base and exponent are functions. The step 1 here, whenever you have base and exponent, so it looks like f of x to the power g of x. So y equal to f of x to the power g of x. That's the way it looks like. So here we notice that if you're asked to find f of x to the power g of x type derivative, then you have to go for logarithmic differentiation. So let's call y equal to x to the power root of x. Then let's take ln on both sides. So ln of y equal to ln of x to the power root of x. So we are taking ln on both sides. So now you can move the root of x in front. So it is root of x ln of x. So what we have is ln y equal to square root of x ln of x. So what is step 2? Take the derivative. Take derivative on both sides. So d by dx of the left hand side equal to d by dx of the right hand side. D by dx of ln y equal to d by dx of root of x ln x. What is derivative of ln y? We know that derivative of ln anything is 1 over ln of something. If when you write derivative of ln of something is 1 over that something times derivative of that something. Correct? So we'll use that. So it is 1 over y, then derivative of y, which is y prime, equal to, now here it's a product of two functions. So let's apply the product rule. This is u and this is v. So if you apply the product rule, so let's say u equal to root of x, v equal to ln of x. What is the derivative of u? 1 over 2 radical x. What is the derivative of v? 1 over x. So it is u v prime, that is 1 over x. I'm applying product rule. So you guys know what product rule is. If you have d by dx of uv, it's u v prime plus v u prime. So here I have written u, then I've written v prime plus v, which is ln x, and then u prime 1 over 2 square root of x, right? Okay. So if I rewrite this, it's root of x over x plus ln of x over 2 square root of x. So what is root of x over x? It's x to the power 1 half over x to the power 1. So it is 1 over x to the power 1 half, which is 1 over square root of x. So this can be written as 1 over square root of x plus ln of x over 2 square root of x. So if I multiply both by 2, I get 2 plus ln x over 2 radical x. So what do we have on the right left hand side? It's 1 over y prime. What I want is only y prime, which means I need to multiply both sides by y. So I get y prime equal to y times 2 plus ln x over 2 over 2 radical x. But what is y though? Y given in the problem is x square root of x. So it is x square root of x times 2 plus ln x over 2 square root of x. So that is the answer to the problem. So whenever you come across with base a function and exponent is also a function, and the question is finding the derivative, then you first do ln on both sides, and then you do the derivative. So this is part 1 of this section 3.6, and then the next part we will discuss about derivatives of inverse trigonometric functions. So watch the next part of the video for this section, which is 3.6, part 2, where we will talk about derivatives of inverse trigonometric functions. In this video, part 1 of the video, you learned about logarithmic derivatives. Then as we come to the exercise, we will do the combination of derivatives of log functions and also inverse trig functions.